Hi, my name is John.
And my name is Alice, and you're watching Math Videos for Parents. We help you so you can help your kids with math. Today, we're talking about writing numbers. So, I, when I was in elementary school, I only learned place values. So, if you see here the number 24, um, I just learned it as that number is the ones value, and the two is the tens value. And I have to say, when I was learning this as a child, that always confused me that like a two in the tens made it a 20. I was like, but I thought you were calling it a tens. So I'm glad to see that they kind of have a new way of thinking about it when teaching place value and writing numbers. So John, can you enlighten us about base 10 blocks?
Sure. So in today's elementary classrooms, the phrase base 10 block is used. And the idea behind it is that all the numbers we write, much like the one that you just wrote, are powers of 10 and include sums of powers of 10. Like 24, we could understand as two tens plus four ones. We can go into the hundreds, the thousands, the tens of thousands, etc. And all those are powers of 10. So it's pretty useful to think of things in terms of base 10. On the more advanced end in high school, students work with logarithms, which have an understood base of 10 unless otherwise specified. So you could think of this as a way to get students used to base 10 very early on in a pretty easy to understand format. So the idea behind base 10 blocks is that each little block is one. We think of it as area. It's a length of one and a width of one. So it just stands for the number one. If we have this long rectangle, we call this a 10 because we have 10 of these ones. So it is a 10 by 1 rectangle composed of a bunch of 1 by 1 rectangles. So this adds 10 to the running sum. Same here. This would be another 10 by 1 very long rectangle that is composed of 10 ones. And then we have these four loose squares, each of which is 1 by 1. So I have four ones here, and four ones is 1 plus 1 plus 1 plus 1, or 4. So if I want to come up with a number represented by these blocks, it's 10 plus 10 plus 4, which is 24. And again, we call them base 10 because these, if you have an understanding of exponents, these are each 10 to the first, but then the one blocks, those are 10 to the 0 power. Those are ones. We define 10 to the 0, or any number to the 0, as just 1. So that's what we mean when we say base 10. The base of the exponent is just 10.
So that's really interesting, John. I find this very intuitive in that you're bundling things in groups of 10, and if they no longer fit, they're kind of the leftovers. They're like the four ones hanging out there. And it's actually so intuitive to bundle things by 10. It's hard to think of a time we don't, but I've thought of one. When you buy donuts, that is not base 10,
No,
right?
it's
You
base
buy
12 or
12
13.
donuts. That's base 12. Okay, so I would love to try a problem where it's written out in base 10 blocks, and I'm going to write the number.
Yeah, let's do that. Go.
Okay, so I'm looking at these base 10 blocks that represent a number, and the first thing I notice is that in this case, which we didn't see in the previous problem, we have this big square. And if you were to count it, it would be 10 by 10. So it's 10 squared. So it's 100. Now, this is a shape that students are going to get really familiar with. If they see this big square of 10 by 10, just looking at it, it's 100. Then here we have the columns that we've seen before, which is just 10 by 1, or 10 to the 1 power. So that's 10. Here's another bundle of 10. So the way I kind of think of it is all these kind of one single blocks were running around, and we just corralled 100 into that sheet. We didn't even have to do it. It was done for us, right? So we're like, okay, there's 100 done. There's 10 done. There's 10 done. Here's another 10. And so all we really have to count is these loose blocks, and that's easy enough to do. We see there's 2. And my understanding, and John, please chime in here, my understanding is the spacing doesn't matter. We're just saying, hey, there's a 1 and there's a 1. It doesn't matter that they're spaced far apart or close together. They're
Correct.
just representing 1 each, which is 2. So looking at this overall, I've got 132.
Great. And to just tie in the whole aspect of powers of 10 and distributing, the students will see later, they could think of this sum as 100 plus 30 plus 2, which also can be thought of as 10 to the second power. So that has a base of 10. 10 by 10 is the area there. And then for the 30, that's 3 of the rectangles with area 10. So that's like 3 times 10 to the first. And then for the ones that you have, there's 2 of those. And because those don't make nice rectangles, we have no rectangles. So that would be 10 to the 0. So each of the places that Alice mentioned earlier, hundreds, tens, ones, we can understand them as base 10. 10 to the second, 10 to the first, 10 to the 0 for the big squares, the rectangles, and the little squares.
I see. Wonderful. That's a really convenient number system we have. And as soon as we stop filming, I'm going to look up why we don't buy donuts in sets of 10, why we buy them by the 12.
It's one of life's biggest mysteries.
Well, thank you very much for joining us. Please let us know if you have any problem requests. Feel free to email us, mathvideosforparents@gmail. Subscribe to our YouTube channel, put a comment on our Facebook page. We really look forward to hearing from you.
Take care.